So good morning to one and all. Today we are going to discuss about transistors. So transistor is a sandwich of one type of semiconductor between two layers of other types. Transistors are classified into two types. One is a PNP transistor and another one is NPN transistor. PNP transistor is obtained when an N-type layer of silicon is sandwiched between two P-type silicon material. So whereas in case of NPN transistor is obtained when a P-type layer of silicon is sandwiched between two N-type silicon materials. So here the transistors usually consist of three terminals. That is, first one is collector, base, and emitter. Here that is I am taking it an NPN transistors. For fabricating this, here the collector region must be moderately doped, whereas your base terminal is lightly doped and it will be of very thin in nature, and whereas your emitter terminal is heavily doped. So next we look on to the schematic and a simple representation of your transistors. So here it is a NPN transistors. It is equivalent to two diodes which are connected back to back. So normally we have two junctions, that is JE and JC. So here it is a PNP transistor, that is emitter, base, and collector, and another one here NPN transistor. For the same you have a emitter, base, and collector. So this is here NPN transistor. Here arrow marks towards in to your base terminals, that indicates a PNP transistor, whereas here arrow marks towards out that indicates your NPN transistor. Next, operating regions of a transistor. The transistor can be operated in three different regions. The first one is active region, second one is saturation region, and third one is cutoff region. So let us discuss in detail about the operating regions of a transistor in an active region. So for an active region, the condition is the base, that is the base and emitter must be in a forward bias condition, whereas collector and base would be in a reverse bias conditions. So if the polarity will be connected in that manner, then we can say that your transistor can be operated in an active regions. So for that, the collector current is said to have two current components. So one is due to forward biasing of your EB, and another is due to reverse biasing of a terminals, that is collector and base junction. So the collector components due to the reverse biasing of the collector junction is called as reverse saturation current, and that current is usually very small in magnitude. Next we discussed about the operating regions of a transistor under saturation regions. So under saturation regions we can say that your emitter base junction must be in a forward bias condition, as well as your collector and base junctions also in a forward bias conditions. I mean that here both the collector and emitter terminals can be tied up with the positive terminals of your power supply. Then you can say that your transistor can operated in a saturation region. When the transistor is operated in a saturation region, Ig increases rapidly for a very small change in a Vc. So this is the conditions for your saturation region. So next we have to discuss in detail about the operating regions of a transistor in a cutoff regions. So for a cutoff regions, both the emitter terminals as well as their collector terminals must be in a reverse bias condition. So when we connect that transistor in such a manner, I mean that here the emitter base junction and the collector base junctions are reverse bias conditions. We can say that it is in a the transistor must be operated in a cutoff region. So in this region, the current transistor is very small in magnitude, and thus when a transistor in this region, it can be said that it is an off state. It indicates that your cutoff, whenever your transistor operates in a cutoff region, you can say that a transistor is said to be an off state condition. So normally in a previous slide we can discuss about the cutoff region. For your active region, you can say that the emitter based junction must be in a forward bias conditions, whereas whereas your collector based junction should be in a reverse bias conditions. For a saturation region, both the terminus, that is collector terminus as well as emitter terminus, can be tied with a positive to supply. Then I can say that it is in a saturation region, and for your cutoff region, your emitter terminus must be in a reverse bias conditions, as well as your collector terminus is also in reverse bias conditions. Then you can say that it is in a cutoff region. That's why you have called as a transistor to be in an off state conditions. Next, we discussed about the current components of a transistor. So the transistor operates in an active region. So for my analysis, I can take for active region, we can know that your emitter terminal can be tied up with the positive terminals of your power supply, whereas the collector terminus is tied up with the negative terminals of your power supply. That means that VEB is a forward bias condition and the VCB in reverse bias conditions. So as the EB junction is forward bias, a holes from the emitter regions flows towards the base, causing the hole current, and at the same time electrons from the base region goes towards the emitter, causing the electrons flow to have called as a I suffix of Ne, and the resultant current, that is a summation of the current, constitutes the emitter current, that is I is nothing but I suffix of Pe plus I suffix of Ne. That is nothing but a collector current is combinations of both emitter current is combinations of both collector current as well as your base current. So next we discussed in detail about the types of configurations, that is based upon the terminus which is common to for input as well as output. We can classify the transistor configurations into three, because your transistor usually have three terminus, that is a base, emitter and a collector. So first one is common base configurations. In this, base terminus is common for both the input terminus as well as your output terminus, and the second one is emitter terminus. For emitter terminus, your base terminus is act as an input, whereas in case of your collector terminus can be act as an output. So next one is collector current configuration. Common collector configurations. In the configurations, your base can be act as an input and the emitter can be act as an output. So now we detailedly discuss about the circuit configurations. The first one is the CB configurations. In case of your CB configurations, we can say that the base terminus is common for both input as well as output terminus. So here input side is the emitter terminus, whereas your output is collector terminus. So if we arrange in this configuration, then we have called as a common base configurations, because your base can be act as an both common terminus for both input as well as your output terminal. Next is CE configurations. For your CE configuration, your emitter terminus is common for both the input as well as your output. Here for CE configurations, your base terminus is common, and whereas your output terminus IC, that is collector terminus, is common terminus for your CE configurations. So in this configurations, that is here you can say that IB is nothing but your input current, whereas IC is nothing but your output current, and IE is nothing but a common point terminus. So next is the CC configurations. For your CC configurations, that is common collector configurations, your collector terminus is common for both input as well as your output terminus. Here the input is nothing but your base terminus. The base terminus is here the current input current is IB, whereas output current is IE, and your collector current is IC. That is this terminus is common for both the input as well as your output. So whatever the configurations it may be, that is here based upon the terminus which is common for both input and output, we can classify your transistor configurations as three. That is common base CB, common emitter CE and common collector configurations C. So thank you.